Alright, so let's look at why water works as a solvent. Why is water a solvent? So, first thing you'll notice about water is it's got this very distinctive structure right here. Okay, so that is how water looks like. So it's basically a commonly used solvent. In fact, it's known as the it's known as the universal solvent. Okay, and what that means is that to a certain degree, it'll probably dissolve everything just a little bit, but it's definitely the most common solvent. The way it works is because it is a polar molecule. And we're about to say it in a second, but we'll write that there now. It's a polar molecule, which what that means is that essentially there is an uneven spread of electrons. So you've got this giant big oxygen atom in the middle here, and these two tiny hydrogen atoms. Now, this guy has usually 6 outer shell electrons just zooming around the place. But because he's got that big positive nucleus in the middle, he draws this little hydrogen's electrons over to this side. So the hydrogen still gets electron there, but they're generally over this side. And what that means is you've got an uneven spread of electrons. So you've got all the electrons are in the middle, and at this point up here, but over here you've got essentially what is a positive proton on the end here. So essentially this is a proton there, and it's just exposed to the end, at the end. And this makes it slightly negative at the oxygen, so we get this symbol here, and you need to sort of know this symbol. That means that end is negative because you have more electrons than protons, and this one you have more protons than electrons, which means it is positive. And it's only slightly, it's just a little bit, but it only needs to be a little bit. And this makes it polar, which means it just has an uneven distribution of electrons. Now, how does this work? Essentially, the water molecules swarm around ions of the opposite electronegative polarity. So, for example, here we have the sodium here is polar. Sorry, is ionic, and it's a positive ion, which means this negative end right here, so this is negative there, these negative ends are all attracted and they surround that ion. Now, if you've got the chlorine atom, which is it's a negative one, what you get is you get the positive ends of the water molecule surrounding it this way. And that's how it dissolves. That's why they become this uniform structure within the water, is because the water molecules rip them apart and sit them in the middle. And we always draw it, by the way, and I've not quite left enough room there. Oh, you know what, let's do it. We always do it as surrounded by 6 water molecules. So the positive ions get surrounded by the negative oxygens in the water, oxygen atoms, and the negative ions get surrounded by the positive hydrogen nuclei. And that's how it looks there. Now, that's when we're dealing with ions, but how does it dissolve molecules? For example, a hydrogen bond. Now, a hydrogen bond is this way. So you see we draw these like hard bonds there. That's a hard bond. So this is actually a sucrose molecule, which is a glucose and a fructose joined together at this oxygen in the middle there. It's called a glycosidic bond. But all these oxygens and hydrogens around the outside here, they're attracted to, that's the little dot means, they're attracted to the oxygens and the hydrogens in the water. So all the big electronegative molecule atoms, like the oxygens, come along and they're like, oh, hey, how you doing there? And the hydrogens are like, oh, hey, how you doing? And they join together. And you get this nice little, again, 6 of them around it. Right, that's 7. But you get this like bubble forming around your sucrose molecule. And it's the hydrogen bonding. This is what allows it to dissolve sugar, essentially. Alright. And that's it.